us some information. 6xy is equal to x square y plus 9y, and the question is asking some value of xy. Now, usually most of the students start solving this question in this way. First they try to find out what exactly can be obtained from this information. So they use it this way. 6xy is equal to y taken common, x square plus 9. Y getting cancelled out. So 6x is equal to x square plus 9. And then they go further with this. If you have done anything like this, write down that this is a wrong way of going forward. This is what? This is the one learning. Why is this wrong? Because you can cancel out the variable in an equation only if the variable is non-zero. This question does not provide us any information about y to whether be 0 or non-zero. Therefore, you do not do that. Then what do you do instead? You still solve this, because I always iterate that the question, if there is any expression, any algebraic expression is given, the first thing is you need to simplify that. So can I rewrite this that y taken common, x square y plus 9 x square plus 9 minus 6x is equal to 0, which further gives me that y times x minus 3 whole square is equal to 0, which gives me y equal to 0 or x equal to 3. Now we have the complete inference of that algebraic expression. That means now either y has to be 0 or x has to be 3, or both also may be true simultaneously, we don't know. Now we go to the statements. Always remember, our objective should always remain to prove that the statement is not sufficient. So now the first statement says that y minus x is equal to 3. Let's use the first solution from the question expression, which is that at y equal to 0, x becomes negative 3 and xy becomes 0. But if we substitute x equal to 3, y becomes 18 and y becomes, my mistake, 6 and xy becomes 18. Multiple values of x into y, therefore not sufficient. The moment we do that, out of the 5 options that we have, we can once again eliminate option A and option D. Now we go to the second statement. The second statement says x cube is smaller than 0, which is possible only if x is negative. That means x itself is less than 0. Now you have to think, how is this information useful for us? Actually, now we have two sets of information. One, either y is 0 or x is 3, and the second, x is definitely smaller than 0, which eliminates the possibility of x to be equal to 3, which leaves us only with y to be equal to 0. And if that is the case, then irrespective of the value of x, xy is always going to be 0. Since we have the unique value of the question, therefore it is sufficient, and then the answer becomes option B. So once again, this is how we look at the data sufficiency question. Always simplify the algebraic expression that we have been given. Never cancel out the variables if you have no information about those variables. In equations, you can always cancel out the variable if it's non-zero. If it may be 0, then don't do that. So to get rid of any such problem, you can always retain them.